Given the derivative of a function f prime of x equals x minus 1 quantity squared times x plus 2 quantity squared, I want to first find the critical points. So for the critical points, I'm going to set each one of the factors equal to 0. And I'm going to get that x is equal to 1 and negative 2. The second step, I need to find where the function is increasing or decreasing. And for that, I'm going to use the first derivative test. I'm going to plug in my critical points on here. And I'm going to test the regions to the left of the critical points and to the right of the critical points. One thing to notice is the derivative is a quadratic times a quadratic. So this thing is greater than or equal to 0, and so is this thing. So whenever you multiply two non-negative numbers, you get a non-negative answer. It's only going to be 0 where the critical points are, and everywhere else it's going to be positive. Okay, so the derivative is only 0 at the critical points, so everywhere else it should be positive. And to convince yourself, you can plug in different numbers and see what values you get. But this is a nice shortcut that saves us a lot of time. Okay, last, let's see if there are any local max or mins. Well, here it's increasing, here it's increasing, and here it's increasing. So in order for there to be a max or a minimum, the function has to either increase then decrease or decrease and increase. So obviously here we don't have any of that. So there are no critical points, but f is increasing from negative infinity to negative 2. And here you don't want to include negative 2 because the derivative is 0. Derivative 0 means there's no change. So it's basically everything, but we're going to use 3 intervals here because we want to break it up so we don't include these points. So this is the first region, this is the second, and this is the third. Let's look at another example. Here we have f prime of x is equal to x minus 1 times x plus 2 times x minus 3. For the critical points, I'm going to set the derivative equal to 0. And I get x equals 1, negative 2, and 3. Okay, now we're going to have our number line. And we're going to put in our critical points on there. And here we want to test the different regions. So there's going to be 4 different regions that we're interested in. But because I'm feeling a little lazy and I want to do this more efficiently, I'm going to recognize that this is basically x cubed. Right? You're multiplying 3 different factors, so it's x cubed. And in the long run, we know that x cubed looks something like this. Now, we don't know what happens in between that. So if we're looking towards negative infinity, it's going to be negative. If we're looking at positive infinity, it's going to be positive. If you're not happy with this explanation, plug in a number. Let's say if I plug in 4 and plug in negative 3. You should get that they're negative and positive. Okay, next I'm going to plug in, let's say 0. It's my favorite number to plug in. So I get negative, positive, negative. So that's going to be positive. Then let's pick a number between 1 and 3. We'll say 2. This is positive, positive, negative. Okay, so that's a negative. So my function is decreasing, increasing, decreasing, and then increasing. Okay, so let's say f is increasing from negative 2 to 1, and then from 3 to infinity. It's always good to not include the critical points because the critical points are, again, where the derivative is 0, and there's no change there. F is decreasing, well, from negative infinity to negative 2, and then from 1 to 3. So at negative 2, we're decreasing and then increasing. So the local min is at x equals -2. And then at 1, it's increasing then decreasing. So there's a max there at x equals 1. At 3, it's decreasing and then increasing. So that's also a minimum. So that is my answer. Okay, last example, we have f prime of x is equal to x minus 7 times x plus 1 times x plus 5. For the critical points, I'm going to set the derivative equal to 0. So each one of these factors is going to be 0. That means x is 7, -1, and -5. I'm going to use the first derivative test, plug in the points, and then test the different regions. So there's going to be 4 different regions that we're interested in. And notice this is still some function of some cubic function. Coefficient will be 1 for x cubed. And then there's some other stuff. So x cubed again looks like this. So this is going to be positive. This is negative. We're going to test different values. Let's say we plug in 0. We have a negative, positive, positive. So that's going to be negative. And then let's say plug in -2. We get negative, negative, positive. So that's going to be positive. So here, f is increasing from -5 to -1, and then from 7 to infinity. F is decreasing from -infinity to -5, and from -1 to 7. Okay, so put the arrows here. And now we can figure out where there's a min and a max. So at x equals -5, it's decreasing and then increasing, so that's a minimum. At -1, it's increasing and decreasing, so that's a maximum. And at 7, it's decreasing then increasing, that's a minimum. And so those are my local maxes and mins.